This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 134. We're on location in College Park, Maryland at the National Centers for Weather and Climate Prediction, or NCWCP. The title of today's presentation is Today's Weather in the Americas Using Satellite Tools. I'm really fortunate to have Dr. Jose Galvez from NOAA's Weather Prediction Center with us today. And the Q&A after the presentation will be facilitated by Orlando Bermudez, meteorologist from the National Weather Service Forecast Office in San Antonio, Texas. Just a few reminders, as you just heard, that this is being recorded. There will be an opportunity for Q&A after the presentation. We particularly encourage questions from our field offices, national centers, and regional headquarters staff. And if you have not signed in using your name, if you ask a question, please indicate your name in the chat so that we can get in touch with you afterwards if necessary. Please also remember to check your spam folder if you're looking for Tower S communications. We've recently been informed that some of our important communications related to satellite imagery for the field has ended up in spam, and nobody wants that. We're also looking for future presenters. If you're interested in being part of our Satellite Book Club, please get in touch with our Tower S team, and the training team can help point you to materials for satellite training that you may be unaware of, or create materials that may be unavailable. So Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank the Tower S team, particularly Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, the GOES-R JPSS programs, all of you for being with us, and of course our presenter and facilitator for today. Jose Galvez has been an instructor, researcher, and forecaster at the NOAA Weather Prediction Center International Desk since 2012, focusing on interpretation of satellite products and numerical models to forecast extreme weather events. Jose, welcome to the Satellite Book Club.
Thank you, Jordan. Thank you for the introduction, for the invitation. It is a pleasure to be here with you guys. Also, thank you to Kashad and Lee, and there's a lot of people I want to thank, but let's make it short. So today what I'm going to talk about is I'm going to do a demonstration of weather briefing over the Americas using English to Spanish consecutive translation. So the background for this is that as part of the WMO initiative and the links with the weather services, WMO has 6 regions in the world. So 2 of them are RA3 and RA4, which are the Americas. And what they do is they do these trainings in satellite image and product interpretation all over the globe. And I work with the team that deals with the trainings for the Americas for RA3 and RA4. So we do these monthly sessions using English and Spanish. You can imagine it's a little bit challenging in the sense that there's a big audience of that speaks different languages. The Americas is mostly English and Spanish, but there's also French speakers, there's also Portuguese speakers, and to a lesser extent, Dutch speakers and so on. So our main focus is to try to reach as many people as possible. Therefore, we do this English to Spanish consecutive translation. And I was with Lee and Jordan as well, and other folks in the RGB workshop last year in Fort Collins, and we thought, you know, why not doing a quick demonstration? So 30 minutes, well, 25 minutes is going to be a little bit short, so I'm going to try to make the most of the build time we have available to speak very briefly about the different tools that we generally use to do these weather briefings, and also try to do the consecutive translation during the briefing. All right, so just as a quick background, I'm going to be using a lot of online tools for this. So I just wanted to tour you very briefly on the process that we usually carry out for these briefings. So first, we want to look into the diagnosis of the large-scale background environment. As you can imagine, there's a lot of tools out there and we have limited time. So we usually look at sea surface temperatures. There's different databases. We're going to look into that. We want to look into anomalies because the anomalies will tell you how different the environment is from what it should be and what impacts you may get out of them. We're going to also look into MJO and other oscillations and equatorial tropospheric waves, which have a very strong impact, especially in terms of rainfall, which is our main responsibility here at the Weather Prediction Center. Then after doing that, we generally look into the distribution of moisture. There's a lot of precipitable water too. It's basically the integration of water vapor in the column. We're going to look into a couple and also anomalies of precipitable water. And then we're going to look into advected layer precipitable water products, which is the same as precipitable water, but in discrete layers in the troposphere. So we can actually evaluate the interaction of different moist plumes. So we're going to look into that a little bit as well. Then we also look into stability indices. There are a lot out there. One that we like is one that we developed at the desk, the Galvez Davidson. So we're going to show a little bit of that. And you know, all these tools also come somehow from satellite data. So even numerical models, without satellite, we wouldn't be able to have decent models at all. And our models are pretty good thanks to that. So we're going to also show hydroestimation very briefly. And then at the end, we're going to move into the diagnosis of the synoptic pattern, which is basically the big systems that are controlling the weather from the upper and mid portions of the troposphere interacting with lower features, and also look into mesoscalar analysis. So we're going to find out which are the regions that have the most critical weather phenomena going on and look into those. That's a quick introduction. These are some of the links that we're using. There are many more, but this is just for reference. And let's start the presentation. So, okay. So I'm going to start looking into sea surface temperatures and anomalies. So if we look at the temperature, if we're thinking, well, first let's talk very quickly with Slider to get a quick snapshot of what's going on in the Americas. So looking at the south, what I'm using here is the Hermas RGB. This is one of these RGB products which are constructed combining very different channels, different satellite channels to highlight different features. In this case, this is the Hermas RGB. So I'm going to start very briefly showing what I'm looking in the RGB and doing this very short translation into Spanish. All right. Okay. So starting with southern and central South America, things that catch my eye are the regions of deep convection, which are shown in white. These are basically deep clouds. But also I'm also looking at this cyclone that is entering the southern cone. This is the Drake Passage in southern Chile and Argentina. And you can see that there's a lot of reds associated with this. So even though this is kind of close to the limb, there may be some stratospheric ozone intrusion associated with this system. So usually these systems with stratospheric ozone intrusions can produce significant weather, not only precipitation, but strong winds. Entonces, lo que vemos ahorita en el sur de Sudamérica, me llama la atención primero las áreas de convección profunda. Me está llamando atención estas áreas de convección intensa en el sur de Perú y Bolivia, sistemas convectivos de mesoescala, y al sur estamos viendo algo que también me llama la atención, es este sistema de baja presión bastante grande, que tiene una coloración roja en este producto de RGB de masas de aire. A pesar de que está muy cerca al borde de la imagen, esto sugiere que puede haber una potencial intrusión de ozono estratosférico con este sistema. Y estos sistemas que vienen acompañados de intrusiones de ozono estratosférico tienden a producir más impactos en términos no solo de lluvia o nieve, sino en vientos también. So these are this is something interesting. Then going further north, we have these MCSs in Peru and Bolivia going on at the moment. Very active pattern right now with this divergent phase of the MJO that is crossing us. And we can see the second branch of the ITCC is very well established at the moment as well into northern Peru and Ecuador. And we have a lot of convection, heavy convection going off in Colombia as well. So very active in western tropical South America. Otra región que me llama mucho la atención es la parte occidental de Sudamérica, la parte hacia el lado pacífico del continente. En estos momentos tenemos un pulso de la oscilación de Madden-Julian divergente, cruzando la zona. Esto está ayudando a que tengamos convección bastante intensa en la región. Vemos estos sistemas convectivos de mesoescala y podemos ver la banda sur de la ITCZ bien establecida y asimismo mucha convección que continúa desarrollándose en Colombia a pesar de que estamos en una parte de ciclo diurno donde no solemos tener tanta convección intensa. Looking at the greens in the image, we usually see a lot of greens in the Hermas RGB. it means that the tropopause is really high, and very likely we don't have a lot of ozone. The ozone, it's very thin. There's not a lot of absorption by ozone, and this is consistent with this deep layer tropical convection environment that we're seeing in Western South America at the moment. Otra cosa que vemos es mucho verde, ¿no? En la imagen del RGB de masas de aire, y eso suele asociarse a una tropopausa bastante alta y a una muy baja presencia de contenido de ozono, ¿no? Que es consistente con una atmósfera de trópico profundo con mucha convección profunda. And to wrap this up, going further north, we can see we have a very robust cold front. Well, I will call it front because it's stationary already over Cuba, but we can see this cold front that goes all the way almost from the North Atlantic, just south of Iceland, all the way into Puerto Rico. It's entering Puerto Rico at the moment, and into northern Hispaniola and Cuba. It is weakening over the Caribbean, but this is a very large system, a long fetch cold front, and we can see all these colder cumulus over Bermuda and over the North Atlantic, and this has this system very likely also has an ozonary intrusion by the reds and the shape of the low associated with the front, ¿no? Y en el norte tenemos algo muy impresionante. Tenemos un sistema frontal bastante grande que va desde casi el sur de Islandia hasta el noreste del Caribe. Está ingresando en Puerto Rico esta mañana, cruzando por el norte de Dominicana y por Cuba, ya en disipación. Tenemos bastantes cúmulos de aire frío detrás del frente. Podemos ver esta nubosidad en forma de puntitos sobre Bermuda y en gran parte del Océano Atlántico Norte. So this is kind of the background of, then I'm going to start looking at the other aspects of the satellite tools to kind of understand better the environment we're looking at. All right, so let's go to SSTs. So we're talking about rainfall. Well, SSTs can affect in different ways, but if we're thinking about tropical rainfall, March in the South Hemisphere is like September in the North Hemisphere. So September is the peak of hurricane season. So now this is the peak of strong, heavy tropical convection in South America. March is very active. So when we're thinking tropical convection, we want to look at SSTs, or sea surface temperatures above 26 Celsius, particularly 27. Whenever the ocean reaches this threshold, usually convection can start developing freely. And we can see that we have, well, 26 Celsius all the way from southern Mexico. Right now, there's a lot of dry air in the region. This is seasonal, so I wouldn't worry much about that. But the 26 are going all the way into central Peru. And then east of the continent, the 26 Celsius are from Cuba and the Bahamas, all the way south into southern Brazil. But we have 28 Celsius from the Amazon Delta into the Rio de Janeiro region in Brazil, also some pockets of above 28 off the coast of Peru, Ecuador, and Central America. Entonces, viendo las temperaturas de mar como base, cuando pensamos en convección tropical, queremos fijarnos en temperaturas que son mayores a los 26, porque generalmente a partir de este umbral empieza a haber convección libre en el océano. Y como en esta época del año tenemos el pico de la temporada lluviosa en la región de Sudamérica, en general en el hemisferio sur, particularmente en zonas tropicales, por el calentamiento del mar, queremos buscar esas temperaturas altas, ¿no? Lo que más me llama la atención es la isoterma de 28, la de 26 también, pero miren la de 28, desde el delta del Amazonas hasta casi Río de Janeiro en Brasil. El agua está muy caliente en esta zona. Y otra región con temperaturas superando los 28 grados es frente a Perú y Ecuador y frente en la costa pacífica de Centroamérica, para tenerlo en mente. Looking into the anomalies, which is another product derived from satellite, as you can see, there's this sharp, large amount of details comes from these satellite observations. We can see that, well, La Niña is wrapping up. We are entering into a neutral ENSO stage at the moment, but you can see that regardless of that, there's already some warmings going on over the Eastern Pacific, and this warming that is going on at the moment between central Chile and southern Colombia is already producing impacts in terms of heavy rainfall in Peru and Ecuador at the moment. So this is something we need to keep in mind. Something else is the Gulf of Mexico is also warm, way above average. This is partly because in the last couple of weeks, we haven't had very significant cold blasts. All the cold blasts has been this winter, mostly in the central and western US, but not a lot in the east. So this also helps warming up SSTs. So this is another region that catches my eye. And also how cold the the northeastern Pacific is. It's very cold away from Canada into the Baja California region peninsula in Mexico. So interesting, very, very, very cool and significantly cool anomalies in this part of the world. Viendo las anomalías de temperatura de mar, me llama mucho la atención estas que están frente a la costa de Sudamérica del Oeste. Estamos ya saliendo de una niña, pasando condiciones neutrales, pero aún así ya hay algunos calentamientos localizados en el Pacífico y estos ya están produciendo impactos desde el norte de Chile hasta Ecuador, ¿no? Es una región de interés. Otra región interesante es el Golfo de México. Tenemos temperaturas por encima de lo normal, en parte por la cantidad limitada de incursiones de aire frío en las últimas semanas en el sureste de Estados Unidos, lo que es diferente en el oeste y en el centro, ¿no? Y esto también parcialmente se refleja en anomalías negativas frente a la costa oeste de Estados Unidos hasta la península de Baja California. Okay, so next, something that I wanted to show is the Madden-Julian oscillations. I have really limited time to explain this with detail, but if you trust me, green means more divergence in the large scale. So the flow is opening in the upper troposphere, and this enhances ascent. So wherever we have systems producing rainfall, these are going to be highlighted, especially in the tropics. We also have some blue contours, which are very hard to see, but these blue contours here indicate that these algorithms that they're running are suggesting the presence of a Kelvin wave, which does the same thing. So we have a lot of factors going on in the Americas that are highlighting deep convection wherever it is occurring, something to consider. ¿No? Entonces, viendo rápido la oscilación de Madden-Julian y otras oscilaciones troposféricas del trópico, tengo poco tiempo para explicar esto en detalle, pero miren el verde, la cantidad de verde en las Américas indica que tenemos un patrón divergente en altura significativo y además tenemos una onda Kelvin troposférica, que son los contornos azules que se ven también, y esos dos factores están resaltando la convección profunda donde está ocurriendo en este momento, especialmente en zonas tropicales. All right, now moving into the precipitable water, I have 7 minutes. I think I can make it. Looking into the precipitable water, this is one of the different products. This is the mimic precipitable water, and catching my eyes is this atmospheric river that is across Polynesia into southern Chile. At this moment, the bulk of the river is still way, way offshore into the Pacific, but there is some connection into southern Chile and this region of the world, similar to Seattle or British Columbia in Canada. They get a lot of rainfall from atmospheric rivers. So this is their dry season, but you know, this can happen all year round. Algo que me llama la atención en agua precipitable es este río atmosférico que va desde la Polinesia hasta el sur de Chile, similar a lo que ocurre en el norte de Estados Unidos, no Washington, Seattle, Canadá. Esta región es muy susceptible a lluvias por ríos atmosféricos, ¿no? Plumas de humedad que vienen de lugares muy remotos. En este caso, esta pluma húmeda está muy lejos todavía de la costa, la parte principal, pero sí hay una conexión que está ingresando al sur de Chile. Something else that catches my eye is that large amounts of precipitable water off the coast of South and Central America into Peru and Ecuador. These are producing a lot of impacts, unfortunately, at the moment, because if you see, the values are almost close to 70 millimeters of precipitable water. That is a lot. That is, and it is a very large area. So this is worrisome, and we actually are working with them to see if we can help them in any way with their rainfall forecasts. So a lot of coordination going on this week. We can also see large values in the Amazon basin, and all this is also highlighted by the MJO. So they are somehow related. The MJO enhances ascent in the large scale, and that will help to pile up water. So that's something that's happening right now. And then the Atlantic ITCC also has very large amounts of available moisture. Viendo el agua precipitable también de la zona ecuatorial, me llama mucho la atención los montos muy altos frente a Ecuador y Perú. Esto está resaltando el patrón actual de lluvias intensas que está ocurriendo en la región. Estamos coordinando mucho con ellos esta semana. También en la Amazonía y también la ITCZ del Atlántico, se ve, ¿no? La zona de convergencia tropical del Atlántico. Estos valores tan altos son favorecidos también por la fase divergente de la Madden-Julian. Como tenemos ascensos favorecidos en gran escala, eso también ayuda a apilar la humedad. Finally, we can see the front, the signature of the front across the Atlantic into the Northeast Caribbean, but these values are more discrete. So precipitable water with this front is about 30 millimeters, which is half of what we have off the coast of South America.
¿no? Y con este frente también hay una pluma húmeda, pero los valores de agua precipitable están cerca de los 30 milímetros, que es la mitad de lo que tenemos en Sudamérica. Okay, 6 minutes to go. Anomalies of precipitable water are also very useful because it tells you how far you are from where you should be. And you can see that most of the Amazon basin, North and South America, is way above average, about 150% or more. And this is what's favoring this rainy period right now. We can also see above average across the southern plains of the US and with the front, but the bulk of it is offshore, is east of the Caribbean, so nothing to worry with that. And these anomalies into southern Chile are also, these areas also above average in terms of available moisture. Y hablando ya de las anomalías, esto también es muy útil porque nos dice qué tan lejos estamos de lo que deberíamos estar viendo como condiciones normales para la época, ¿no? Y vemos que toda esta zona ecuatorial de Sudamérica, de las Américas, ¿no? Desde Centroamérica hasta Sudamérica está muy por encima de lo normal, cerca de 150. Los montos por encima de lo normal con el frente están más al este que el Caribe, no me preocuparía mucho. Valores bastante altos en el sur de Estados Unidos y también con esta pluma en Chile. Advected layer precipitable water, I'm just going to go quickly because I'm running out of time, but this shows the different layers. So I'm not going to spend too much time on this. Looking at the indices, stability indices, the Galvez-Davison index for right now, and we can see that there's a lot of red means there is an environment favorable for deep convection with potentially heavy rainfall, and we can see this is consistent with the large values of precipitable water we're seeing, and we're going to quickly see the synoptic pattern associated with this. Entonces, viendo Sudamérica rápidamente, el índice Galvez-Davison, vemos que hay valores muy altos en toda la zona amazónica y el oeste, que es consistente con lo que hemos visto en los otros campos, ¿no? Hay mucha inestabilidad favorable para desarrollo de tormentas profundas. All right, in the North Hemisphere, you can also see the front in the Galvez-Davison index, but this gray, there's a lot of gray in the north, meaning that in colder climates, we're in winter in the US right now, it doesn't work as well. This is more for tropical convection. So this will work in the summer in the US, but not much in winter, ¿no? Y viendo el índice Galvez-Davison para el sur, vemos, para el norte, vemos que no funciona tanto ahorita en el norte de Estados Unidos por el tema del invierno. Just gonna pass this, the hydro estimation. Okay, so let's start looking at slider. We already saw very quickly the synoptic situation, but just to highlight a couple of tools with slider in the few minutes that I have left. This is one product that we've been discussing that is very useful. This is called the fire temperature RGB, and this helps us to visualize fires. It uses 3 channels that are highly sensitive to hotspots or areas with very hot temperatures. And normally this time of the year, there's a lot of fires in North and South America. This year, there are not that many, which I guess is good news. But we can see these red dots that we can see in the image are the fires that are occurring in Venezuela. They're in the middle of the dry season, so we can see some of these fires highlighted by this product. I'm just gonna go through all in English to be able to finish. Another product we were discussing, well, these are other products that we were, not this one. I have too many. Okay, let's do it here. Okay, so another product we were discussing that with Orlando Bermudez earlier today, okay, that is very useful is this Day Snow Fog product. So this is another RGB that is really useful, and Orlando found it very useful, and other people too. So this will help us to visualize areas with deep convection. So it tells you about different types of cloudiness. For example, in this image, we can see these faint purplish clouds. These are cirrus clouds, so these are just, they won't do anything significant. They're in the upper troposphere. But the deep convection looks pink and red. So these are the areas where you might be receiving some heavy rainfall. You can, snow also looks red. Let me see if I can go into the, yeah, oh yeah. There you go. In the northern US, we can see all this red. This is all the snow accumulated on the ground in Colorado, Wyoming, and Canada. Well, it's March, early March, so almost all of Canada is covered with snow right now. So this is a great product. You can also see some of the features of the vegetation with this. So you can see actually drier areas look greener in this product. So it's a little bit counterintuitive, but you have others that are more intuitive for this. But you can still see some of the variability of the vegetation in this product. And then low clouds look whitish, and you can see some oranges with the front, meaning that east of the Caribbean, there is some vertical development. And to finalize, I have 1 minute, right? Well, I'm past 3, but I was told 12:28, so I think I can do 1. And the day cloud phase distinction, and I'm going to finish with this one. You can already tell there's not enough time for a good weather briefing in half an hour, but this is the day cloud phase, and this is also a product. Personally, I really like it. It also helps you to visualize the different stages of clouds. So whatever we have in yellows and oranges are clouds that have ice. Orange and red is mostly cirrus, but whenever you see these yellows, it's a thick ice cloud, meaning, and because of the shape, these circular type features indicate that these are thunderstorms. So this is really good to analyze when the storms are starting to develop whenever you have these convective initiation environments, like the US in the summer, or in this case, in the tropics, it happens almost everywhere. And okay, 12:28, so thank you.
Excellent. Thank you, Dr. Galvez, for an excellent presentation. I enjoyed it. Really, really well presented. As you mentioned, 30 minutes is not enough to go through all these great tools that you presented today and what the satellite world have to offer us, the forecasters. And as you mentioned earlier, my favorite are the microphysic, the low clouds of stratus, and the temperature, the fire temperature satellite imagery. Those are the best that I really enjoy to use here. But by the way, since you already ended your presentation, I would like to say that to stick around for the discussion that we are going to have, and also to encourage the attendees to please ask questions on the question box, and please put your full name so we know who you are. And please take a few moments to go through the feedback survey that is going to be highlighted at the question box. And by the way, next week we're going to have another great presentation. This time around is going to be from Larry Brown from Axion. We'll be discussing making the most of ghost imagery for WFO. So make sure that you mark your calendar now, and be sure to be here next week at the same time. And also, if you have questions and you like what you saw today, please go ahead and contact the team. The total operational weather readiness satellite team. There you go. You have the information presented in the screen. Please reach out to them so you can, if you have any questions related to any of the tools that were presented today and you want it to be installed in your AWIP system, they're going to be more than happy to help you out with that. So let me go ahead and say, like, hey, Jose, to break the ice before we start getting comments with the audience, which is your best tool that you use the most, or which is the tool that you like the most? I know that you went over them and you have a lot of tools that you can use. Can you share with us which one is the one that you like the most?
Thanks, Orlando. Yeah, tough question to answer because I like a lot, and you know the best way to use this is combining different tools. So if you make me choose one, you know, and I have to think a lot, maybe this is the one I have online because of what I do. Since we work mostly with heavy rainfall, and part of this is coming from convection,
I do like a lot these day cloud phase distinction RGB. I just overlay GLM as well. I didn't have time to talk about it, but GLM is really useful as well. Lightning help us to see which convection could be producing severity and or could be increasing in coverage and intensity. So I would pick this one if you make me choose.
Great, excellent. Thank you for sharing that. And we have the first question, and the person mentioned great talk, and that came from Timothy Smith. And here is the question: are there any other goals level 2 products used depending on the situation, such as the TPW or the atmospheric instability or aerosol optic depth?
Great. Hi, Tim. Thanks for joining. And yes, definitely we look into other goes to level products. The list is very long. I don't know if I can provide a good answer right now, but yes, we look into a lot of other products. I could probably answer better via email because this is a long list. Yeah.
And now that you mentioned your email, please feel free, the people in the audience, if you want to reach out or want some more information, please contact Jose too as well if you want more details on this excellent tool that he showed today. And I know that we need another hour or two to go through the entire series of different tools. I don't see any more questions coming in. You can put a comment into the into chat saying that if you want to speak out, we can definitely take those as well. All right, I do have a question, and that is, can you go really quickly over the index that you created, that you developed?
Over the Galvez Davidson Index? Yeah, sure, I could do that, definitely. And before continuing, I also wanted to mention that as part of the work that we do these different trainings, right? I mean, this somehow is a little bit of training as well, very briefly, but we also do these satellite workshops. So speaking with the group here, we just wanted to say that we have at the next RA4, which is Caribbean, Central America, Mexico satellite workshop coming at the end of March in El Salvador, but there's a virtual component. So anyone who's interested, just send me an email and I can place you in contact with the organizers if you wanted to attend. I just wanted to say that. Okay. Yeah, let me go back to the website of the GDI. Okay, so yeah, we have the Galvez Davidson Index is an index that we developed in 2013. We finalized it in 2014, and we released it kind of officially in 2016, but we've been using it for a long time, almost a decade, and it's working for most people in the tropics and subtropics. So I'm going to try to go briefly over these, over what it is. But basically what I have here is the website that we have, WPC. It's linked to our website, and you can see operational loops for basically all the globe. We started with North America and South America, which is a region of responsibility, or the region we work with, but then we had the African desk saying, hey, this is great, we want to use it, so we made a domain for Africa, and we ended up doing it for all over the world. So as an example, you can see the Pacific, you can see the South Pacific convergence zone very, very well established. There's a tropical cyclone here. You can see by the shape of the system, so you can get an idea of these tropical cyclones as well. They will show up in the GDI, moist plumes in the North Hemisphere, and so on. So anyway, so this index was developed with the goal of trying to help with the forecasting of thunderstorms in tropical locations, because a lot of the traditional indices had been developed mostly for the extratropics. So whenever you apply them to the tropics, sometimes they will work, sometimes they don't. So I mean, at the end of the day, you cannot trust something that sometimes works, sometimes doesn't, right? So we tried to develop something that would work more consistently for the tropics, and this helps a lot, actually. People are happy with it. We were very happy, and then when people started using it, they realized, well, it works. So let's see if I can do this briefly in like 3 minutes. 1 second. Okay, so this is, we have the manuscript linked to our website. Basically, the GDI
is an index that is based on data from 4 levels of the atmosphere. So as long as you have, let's see, this is probably a good graphic. Well, yeah, as long as you have temperatures and mixing ratios and 4 levels of the atmosphere, which are 950, 850, 700, or 500, you can calculate it. So you can calculate it from soundings. It doesn't use wind, so it's a thermodynamic index. So you can calculate it from soundings, from model data, from satellite-derived fields, etc. As long as you have those 4 levels. So let's see. I'm not doing a good job by showing the manuscript. I'm trying to find the right images. So basically, it considers 3 processes. One of the processes that considers is the amount of moisture and instability in the column. So it uses theta E a lot, equivalent potential temperature. It looks into areas where you have these deep columns of large values of theta E. These are usually associated with thunderstorms in the tropics. And in the tropics, sometimes what happens beforehand conditions the environment for future convection. So it's not that we're diagnosing just what's going on, but actually when a cumulonimbus dies, a large area of convection dies, that environment could be the predecessor of future convection. So that's basically the philosophy behind it. So we're looking at that. That's one factor. Another factor we look into is the trade wind inversion, which is the temperature inversion over the trade wind atmosphere. So basically, if you have this these increases in temperature with height, it's a stable layer, so convection can grow. But we also have drying. A lot of times in the tropics, you have a lot of dry air above the marine layer, especially in the dry season, like right now for the Caribbean. So those 2 factors inhibit convection, right? So we also look into that. We look into the drying and also into the lapse rate. And then finally, we look into mid-level temperatures. We use 500 hectopascals. Almost every stability index uses that because it works. So the colder the mid-troposphere, the less stable it is. The warmer, the more stable. So playing a little bit with mathematics with these 3 main factors, we came up with an index that works decently well for the most part to kind of assess the potential for different types of tropical convection. That's it.
Excellent. Jose, if someone is interested to get into these information, how can is it easily obtained over the web?
The GDI or
the paper that you just showed?
Yeah, it's here. The GDI website is linked to our website, the international desk. So yeah, you can find it. It's here also on the tab on the left. But yeah, so we have the PDF here. People have used it to code it in different parts. We have the operational products, and then we have some descriptions, some PPTs. We need to update some stuff here, but you have sufficient material there. Yeah.
Awesome, thank you. So I have one more question and a comment. I want to be respectful of everybody's time. And the question goes like this: what meteorological feature in satellite imagery do not easily translate from English to Spanish?
Or the other way.
There are many. You caught me there. I have to think a little bit further with that. But yeah, there are many. So what type of feature in satellite imagery does not translate properly from English to Spanish? There are a lot of answers. I just cannot think of one right now. There are many.
It's difficult, and the thing is that the way you presented it feels like it's so easy to translate when you did the first part in English and then you translated the same information into Spanish. The thing is that it takes a lot of time to go ahead and do so. To be able to conduct a presentation with doing a bilingual presentation is not something easy. It takes time. And I would like to mention a comment from they said that the WFO1 used your index for the Pacific Islands. So they're saying thank you, Jose, for that. So your work is being all over the world.
Thank you. Yeah, well, this index was also Mike Davison, so I want to credit him. And then actually we have Bonnie Acosta here. She's also a great part of our desk. Jay Alamo is not here at the moment, but he's also part of our group. So this is all a team effort. So thank you for the recognition. Yeah.
Super excellent. So I have a few more minutes, and I would like to open it to the floor for any last comment. I hear none. So thank you so much for the audience for being here today for this presentation about satellite in the Americas. Just remember, next week we're going to have another excellent presentation. Please don't forget to fill out the feedback survey. That is super interesting. And if you need to contact the team, please do so. They'll be more than happy to help you out. With that, I'll say thank you for the invitation for me to be a facilitator during this presentation of satellite in the Americas. And with that, thank you so much. Appreciate your attendance. I'll pass it on to Jordan.
All right, thank you, Orlando, and thank you so much, Jose, for I think what was probably the first bilingual satellite book club. So that I thought was absolutely outstanding. Thanks everybody for joining us today. I think Orlando already has covered that the Satellite Book Club continues each and every week, and so we're looking forward to having Lori Brown with us next week to talk about the GOES satellite imagery that is online recently for the WFOs on the GOES star page. So if you're interested in using that data that's online, that imagery online from GOES as part of your field briefings, please return to us next week. And also earlier this week, the GLN moved to over the SBN, which was an incredible milestone. Thanks to everybody that helped with that. And if you're in an office, make sure that your RPM is up to date so that you are getting the latest and greatest, and our Tower S team can help with that. So we'll wrap it up there for today. Once again, thanks to our presenter, our facilitator, all of you, everybody in the room, particularly Kashad and Lee, everybody that helps each and every week with the Satellite Book Club. We'll see you next week. Thanks. Take care, everybody.